Recursion to splitOdd10. Given an array of ints, is it possible to divide the ints into two groups so that the sum of one group is a multiple of 10 and the sum of the other group is odd? Every int must be in one group or the other. Write a recursive helper method that takes whatever arguments you like and make the initial call to your recursive helper from splitOdd10. No loops needed. So let's go over the sample cases first. So here we have the case 5, 5, 5. In this case, we can make it so that one group consists of 5 and 5, and the other group 5 and 5, and the other group consists of element 5. In this manner, group A, which is the first group, has a sum multiple of 10. This other group has a sum that is odd, and therefore we will return true. Next, we have this case where it's 5, 5, 6. Here, no matter what we do, we cannot create a group, one group, that has a sum multiple of 10, and another group that has a sum odd. The reason why is because the only way we can create this array, create a multiple of 10 with the elements in this array, is by adding 5 and 5 together. However, by doing so, we leave 6 by itself, and 6 is not odd. Therefore, it is impossible to satisfy both cases, and we should return false. Here we have the array 5, 5, 6, 1. If we have one group with elements 5 and 5, and the other group with 6 and 1, the sum of this group is 10, the sum of this group is 7. This is a multiple of 10, and this is odd. Therefore, we do have a case that satisfies the conditions, so we should return true. So how do we solve this question? So note that a prerequisite of this problem is to question split array, which is the previous problem. So it was this problem, and the way we solved this problem was by going through the array, and at every single point, at every single element, we either choose if it goes into group A or into group B. At the end, after having assigned every single element into group A or B, we check the sums, and if the sums were equal, then we return true. If the sums were not, then we returned false. So using that approach, we can also solve this question. At every single point, our recursive step is the same. At every single element, so for example, if we are at 5, 5, 6, 1, and our pointer is currently pointed at 5, at this step, we can either assign 5 into group A or into group B. So this part is the same. Note that here, we will be assigning group A as a group that should have a sum that is a multiple of 10. We will make it so that B is a group that has a sum that is odd. The reason why this works is because we will be going through every single possible grouping of this array, therefore it really doesn't matter which one we make. We can even make A equals odd and B equals a multiple of 10 and this will still work. We're just arbitrarily defining these two groups based on the conditions given. So from this, our recursive step, as I said before, is the same. 5 can either be placed into group A or into group B. Our base case, however, is slightly different. If we are currently at a place that is outside the array, we're pointed at a place outside the array, which means that we already looked through all of these elements and assigned them to group A or B. We now have to check if the conditions are satisfied. We cannot change A and B groupings any further in this particular case because all of them were already assigned, and that is why we are currently at this position. So here we check if this satisfies the conditions. Is A a multiple of 10? And is B odd? If both of these conditions are satisfied, then we return true. Otherwise, we return false. The way we will be doing this is by using the modulus operator and the bit operators. So first, we will be checking if it is a multiple of 10 by checking if A mod 10 equals 0. This just checks what the remainder is if A is divided by 10. And if A is a multiple of 10, then A mod 10, or the remainder of A after being divided by 10, should be 0. To check if it is odd, we will be doing B mod 2 equals 1. So for even and odd, as you probably already learned, 0, 1, 2, 3, 4. It's even, then odd. Even, then odd. They are paired into groups 2, and they alternate every 2 elements. So by doing B mod 2 equals 1, we just check if B divided by 2 and the remainder is 1. If the remainder is 1, then it is odd. If the remainder would be 0, which is the only other case, then we know that it's even because it is a multiple of 2. Finally, we check if both of these conditions are satisfied by using the bit operator AND. By doing so, if they are both true, we return true, and otherwise we return false. So now let's implement this process. So let's start with our recursive helper function. So our recursive helper function comes as follows. So public boolean recurse. Our parameters are the same as the question split array in that we have one pointer pointing at where we are currently at. One variable storing the sum of group A, another group variable storing the sum of group B, and the element list nums. Remember that A is the the group whose sum should be a multiple of 10 at the end, and B is the group whose sum should be odd at the end. So the base case is if I is pointing at an element not in the array. So like so. This again means that I is at a place outside of the array, and we already looked at every single element and placed them into group A or B, so we are basically done and we have nothing else to do, which is our base case, of course. Then we just check if this is satisfied. So we return if both A is a multiple of 10 and B is odd. Next, we should do our recursive step. Our recursive step is the same as the previous question. So we either assign element I into group A, making so the new sum of group A is A plus nums I, B is untouched, nums is untouched, or we again go to the next element here, and then B is where we place the element I. Nums is again untouched. So finally, we will be adding our helper function and returning the answer of our helper function into this problem. So the way we will do this is by initializing, starting off the process with the pointer starting at the first element in the array, which is 0. Group A and B both have nothing inside of them, so their group sums are 0 and 0. Finally, nums is just nums. So let's run this. And here, it works.